Welcome to the first webinar of the series Automatic Control Design of the Amazing Ball with the EICASLab suite, specifically devoted to describe how it is possible to easily implement all the steps of the Amazing Ball control design just using a standard multi-core PC named EICASLab RCP platform equipped with a Linux real-time operating system and with the EICASLab suite. This webinar, named EICASLab Flex Module and Amazing Ball Description, in details includes an overview on the EICASLab software suite, including tools and features specifically studied to drive step-by-step along all the control design phases, starting from modeling and simulation, moving to the rapid control prototyping, ending to the automatic code generation for the final target, the hardware in the loop, and the final in-field validation tests. Then, a description of the 3 control design operative modes available in EICASLab follows, named Modeling and Like Real-Time Simulation, Rapid Control Prototyping, and Target Operative Mode. We will then highlight the new add-on called EICASLab Flex Module that enables to build ERIKA enterprise applications. To show a practical use case, the evidence Amazing Ball is presented. Amazing Ball is a complete, ready-to-use system for learning and teaching real-time automatic control. It consists in a steel plate pivoted on a central joint. The system has 2 degrees of freedom, ensured by 2 servos connected to the plate, with a high-resolution touchscreen that measures the coordinates of the ball mounted on top of the plate. A Flex Demo 2 board controls the hardware using ERIKA Enterprise. EICASLab, the professional software suite for automatic control design and forecasting, represents an innovative approach to the design of automatic controls in several fields such as robotics, aerospace, automotive, machine tools, and special purpose machines. EICASLab supports the automation of industrial processes through powerful tools for modeling plants, designing and testing embedded control system architectures. EICASLab assists the developer in all the phases of the control design process, from system concept to generation of the code to be transferred in the final target. The control design process, that is composed by several control design phases, in EICASLab is addressed by 3 main operative modes that now we will describe. EICASLab offers specific tools for every task of each operative mode. The first operative mode is the modeling and like real-time simulation, in which you work in an entirely simulated environment. You implement your plant model and your control strategy using the Sim Builder tool, and you can perform through the MPI CPO Manager tool the model parameter identification specifically devoted to identify the parameters of your plant model, and the control parameter optimization specifically devoted to optimize the control algorithm parameters. Then you can perform like real-time simulations using the Sim tool, which represents the first level of test of your control strategy. You can finally post-process any data obtained during the simulation using the Post tool. The second operative mode is the rapid control prototyping, a process which lets quickly test and iterate the same control strategies tested in the simulated environment on a standard personal computer equipped with a real-time operating system and with real input-output devices. In such a phase, the slow motion technique can also be applied that like a sort of moviola, allows step-by-step the offline repetition of the experimental trial executed on field. The third operative mode is the code generation for the final target, consisting in generating the final code for the specific target and in validating the system functionalities. Specific tools help the designer to carry out this phase and the relative tests that, in some cases, can foresee the assistance of a monitoring PC or, if needed, an hardware-in-the-loop configuration. Thanks to EICASLab ERIKA cooperation, the new EICASLab Flex module is now available. The Flex module is an add-on for EICASLab Suite that allows the developer to design, directly into EICASLab, applications for Flex boards equipped with the ERIKA Enterprise kernel. Thanks to the new Flex module, it is now possible to automatically generate applications running on single and multi-core embedded systems equipped with the ERIKA Enterprise real-time kernel like the Flex boards. The user can directly build, in a simple and effortless way, the whole firmware to be flashed or loaded into the selected Flex board target. Thanks to EICASLab ERIKA integration and cooperation, EICASLab is able to generate code that exploits the ERIKA Enterprise kernel features and that is ready to be compiled with the Evidence Real-Time Duo tool. The Evidence Amazing Ball platform has been selected as use case for showing the functionality of the new EICASLab Flex module, specifically conceived for developing application for Flex board targets equipped with ERIKA Enterprise real-time kernel. The Amazing Ball platform consists in a steel plate pivoted on a central joint, on top of which is placed a metal ball free to move. The system has 2 degrees of freedom, ensured by 2 servo drives connected directly to the plate that allows to tilt it. The coordinates of the ball are measured with a high-resolution touch panel mounted on the plate surface, while a Flex Demo 2 board equipped with Microchip's DS-PIC33F microcontroller and ERIKA Enterprise kernel commands all the peripherals. The control strategy aims at controlling the metal ball position on the steel plate. For doing this, it will exploit the Amazing Ball platform peripherals for closing a position control loop. The use case objective is to show how it is possible to develop in EICASLab the control strategy for the Evidence Amazing Ball platform. The control strategies aims at controlling the metal ball position on the steel plate. For doing this, it will exploit the Amazing Ball platform peripherals for closing a position control loop. Starting from the measured ball position on the plate, the control strategy calculates the commands necessary to activate the servo drives that, tilting the plate, cause the ball to move towards the desired direction. Although the use case appears to be simple, it shows some characteristics useful for didactical purposes, such as static and kinetic friction and non-linear effects between the drive movement and the plate rotation that affect the control performance. To develop in EICASLab the strategy for controlling the metal ball position on the steel plate, the 3 operative modes have been applied directly at the use case. The modeling and like real-time simulation, the EICASLab operative mode specifically studied for supporting the user in designing the overall control strategy and preliminary assessing its performance in a powerful simulated environment, able to faithfully emulate, like real-time, the expected final software and hardware architecture. For running this operative mode, you only need a standard PC equipped with Linux or Windows operative system and with the EICASLab suite. The second operative mode is the rapid control prototyping that allows the designer to validate the same control code, the application software, already tested in like real-time simulation, now executing it in real time by using the EICASLab RCP platform. That is a single standard multi-core PC equipped with the EICASLab suite, with a Linux real-time operative system and suitable hardware input-output devices, which is able to pilot the real plant. The operative mode includes the automatic code generation of the basic software necessary to manage the RCP platform. Then, the target operative mode that allows the designer to automatically generate the basic software necessary to run in the final hardware target the same control code, the application software, already tested in the previous operative modes, to execute in real time the hardware in the loop and on-field validation tests. This operative mode can be again exploited by using the above-mentioned EICASLab RCP platform, suitably connected with the final hardware target. In the next webinars, each operative mode carried out on the Evidence Amazing Ball platform will be detailed separately. This webinar stops here. The next webinar will deal with the modeling and like real-time simulation operative mode exploited for the Amazing Ball use case. Thank you for your attention. For any other information, please visit www.eicaslab.com.